Good day, everyone. Welcome to 5 minutes with Faraday. The subject I'll be taking a look at today is mathematics, and the topic is integration. I'm going to explain how to solve integration by trigonometry substitution. Now, there are three ways we can solve integration by trigonometry substitution. We can use sine theta, we can use tan theta, we can also use sec theta. So, for today's class, I'm going to explain how to use sine theta to solve question on trigonometry substitution. Now, when you have something like this, a squared minus x squared. Now, this a can be anything. A can be 9, it can be 4 or any other number. So when you have something like this, a squared minus x squared, you have to use this. X is equal to a sine theta. Now, let's take an example. Example 1. Integral of 1 over the square root of 4 minus x squared. Now, this 4 is you can also rewrite this as 1 over the square root of 2 squared minus x squared. Therefore, it obeys this rule. So we can say x is equal to, the value of our a here is 2 sine theta. Now, the x over the theta is equal to 2 cos theta. When you cross multiply, we have the x is equal to 2 cos theta. Now the theta. Now we are here 1 over the square root of 4 minus, here we said x is equal to 2 sine theta, so 2 sine theta all squared. So we are going to have 1 over the square root of 4. Okay. 2 times 2, that's 4. Sine theta times sine theta, we have sine squared theta. Now, that reminds me, the x is supposed to be here, the x. And now, we say dx is equal to 2 cos theta d theta. So put it here, 2 cos theta, now the theta. So here we have 1 over the square root of, we have 4 here, we also have 4. So 4 is common, factorize it out. We are left with 1 minus sine squared theta. Now we have a trigonometry identity that sine squared theta plus cos squared theta is equal to 1. So we can say cos squared theta is equal to 1 minus sine squared theta. Here we have 1 minus sine squared theta and it's equal to cos squared theta. So we have 1 over the square root of 4 cos squared theta times 2 cos theta d theta. Okay, so 1 over, what is the square root of 4? 2. And what is the square root of cos squared theta? That's cos theta times 2 cos theta d theta. Now, 2 cancel 2. Cos theta cancel cos theta. We are left with what? 1 d theta, 1 d theta. So what is the integration of 1 here? That's theta plus c. But in the question, we are given x, the x. We are not to leave it as theta here. Now, let's come back to this place. Here we have x is equal to 2 sine theta. So divide both sides by 2. Sine theta is equal to x over 2. So theta is equal to the sine inverse of x over 2. So here we have sine inverse of x over 2. So replace it here. The sine inverse of x over 2 plus c, or we can call it arc sine x over 2 plus c. Now let's take example 2. We have x over the square root of 1 minus x squared. Now the x. Now we have 1 minus x squared. Let's see if it satisfies this rule here. So we can also say 1 squared minus x squared. Why? Because 1 times 1 is also 1. So x is equal to a sine theta. X is equal to, the value of our a here is 1 sine theta. So let's say the x over the theta is equal to cos theta. So cross multiply. The x is equal to cos theta, now the theta. So we are here. Now x is what? Sine theta. Sine theta over the square root of 1 minus sine theta all squared times the value of our dx here is cos theta d theta. So sin theta over 1 minus sin theta squared is sin squared theta times cos theta d theta. Now, I gave us this trigonometry identity. Cos squared theta is equal to 1 minus sin squared theta. So we bring it here. Sin theta over 1 minus sin squared theta is cos squared theta times cos theta d theta. So sin theta over the square root of cos squared theta is cos theta times cos theta d theta. So this cancels out this. We are left with sin theta d theta. So what is the integration of sin theta? We have minus cos theta plus c. Now we can't leave it like this. We have theta here, and in the question it is x. So don't forget we said x is equal to 1 sin theta. So we can as well say theta is equal to the sine inverse of x. Let's say x over 1. Now this is cos and this is sine. So what do? Now you know sine in SOHCAHTOA. So sine is opposite over hypotenuse. Therefore this is our opposite and this is our hypotenuse. Here we have cos. Cos is equal to adjacent over hypotenuse. We have our hypotenuse to be 1. So what's the adjacent? Let's find the adjacent using Pythagoras Theorem, which says what? Hypotenuse squared is equal to opposite squared plus adjacent squared. What's our hypotenuse here? 1 squared. What's our opposite? X squared. Plus, what's our adjacent? Unknown. So this is plus x squared. When it's cos, it changes to minus. We have adjacent all squared here. Now, to cancel out this square, we introduce what? Square root. 1 minus x squared is equal to adjacent. So cos here, cos theta now here is adjacent, the square root of 1 minus x squared over hypotenuse 1. So we can say this minus sign here minus the square root of 1 minus x squared plus c. Okay, let's take the last question, question 3. The integral of x over the square root of 16 minus x squared dx. Now we have 16 minus x squared here. So we can as well say it is 4 squared minus x squared. Therefore, from this, x is equal to a sine theta. The value of our a here is 4. X is equal to 4 sine theta. So the x over the theta is equal to 4 cos theta. So cross multiply. We have the x is equal to 4 cos theta d theta. Now come back to this. The value of our x is 4 sine theta, 4 sine theta over times the x here is 4 cos theta d theta. 16 minus x, 4 sine theta, all squared. So we have 4 sine theta times 4 cos theta d theta is equal to over the square root of 16. 4 times 4, 16. Sine theta times sine theta, sine squared theta. Now here, 16 is common. So bring it out. Now we have 1 minus sine squared theta. As usual, 1 minus sine squared theta is equal to cos squared theta. So we have 4 sine theta times 4 cos theta d theta over the square root of 16 cos squared theta. Okay. Now, we know the square root of 16 is 4. And the square root of cos squared theta is cos theta. Now, we have 4 cos theta here. We also have 4 cos theta here. So it cancels out each other. We are left with 4 sine theta d theta. Now, let's integrate 4 sine theta. We are going to have minus 4 cos theta plus c. Now, we have theta here. Now, we have to, instead of x, so let's do it like this, the way we've been doing it before. Here we have x is equal to 4 sine theta. Let's make this theta the subject of the formula. Divide both sides by 4. we have the sine theta is equal to x over 4. Therefore, theta is equal to the sine inverse of x over 4. But here we have cos and here we have sine. Now, sine, so in SOHCAHTOA, sine is opposite over hypotenuse. Opposite, hypotenuse. And cos is adjacent over hypotenuse. So we need the adjacent here. And what do? We use Pythagoras theorem, which is hypotenuse squared is equal to opposite squared plus adjacent squared. So what's our hypotenuse here? 4 squared. What's our opposite? X squared. What's our adjacent? Let's use y here. So what is 4 times 4? 16 minus, this is plus x squared. When it's cross, it changes to minus x squared is equal to y squared. To cancel out this squared, we take the square root. 16 minus x squared is equal to y. Now, cos, these are adjacent. Adjacent is equal to the square root of 16 minus x squared. And cos is equal to cos theta, adjacent, 16 minus x squared over hypotenuse. And what's our hypotenuse here? 4. So we have minus 4 times the square root of 16 minus x squared over 4 plus c. Now, 4 cancel out 4. So we are left with minus the square root of 16 minus x squared plus c. Now, this is the end of this video. In the next video, I'm going to explain how to solve using sec and how to solve using tan also. So if you haven't subscribed, please do that so as to get notified when I post another video. Thank you.